This video describes the two different models of AI in Indian agriculture, which are complementary to each other. Most people are aware of the government-promoted AI models. However, there is another model. We discuss the pros and cons of both and how they can be used to improve agricultural practices in India.
Digitizing a vast agrarian economy of 11 crore smallholder farmers is currently the largest technological deployment in global agriculture. Right now, two distinct technological models are attempting to execute this transition, creating heavy friction for investors and builders trying to place their bets. The first is the Government of India's approach, a top-down digital public infrastructure designed to build a national nervous system. The second is the SMART FPO model, a bottom-up operational AI network built to serve as hyper-local muscle for community farms. These two systems solve different problems. Real agricultural ROI depends on how you bridge the gap between administrative scale and industrial execution. To evaluate where capital should go, look at this matrix. The y-axis maps action. The bottom manages records and subsidies, while the top executes physical farm tasks. The x-axis maps data. The right uses broad national trends. The left relies on plot-specific soil sensors. Any solution aiming to fix Indian agriculture must be mapped against these four quadrants. This reveals exactly what a tech model can execute and where its structural blind spots lie. We start with the government's top-down infrastructure, specifically IDEA, the India Digital Ecosystem for Agriculture. This is built to be the ultimate public policy layer. The core input of this model is data consolidation. It takes disparate legacy land records and centralizes them, assigning dynamic, federated farmer IDs to millions of individuals. That input creates a single source of truth. It stops the leakage of subsidies to ghost intermediaries and automates roughly 2 lakh crore rupees annually in direct cash transfers and crop insurance payouts. When we plot the government agri-stack on our matrix, it lands perfectly in the bottom right. It achieves maximum national scale and completely dominates administrative action. The government model also employs the Krishi Decision Support System, using satellite macro surveillance for digital soil mapping down to a 1 to 10,000 scale. This level of geospatial tracking gives policymakers predictive accuracy for managing national food security stocks and allows them to issue broad regional fertilizer recommendations. However, relying exclusively on macro data presents a severe trade-off. Satellites tracking regional weather patterns leave the individual smallholder completely blind to micro variations, soil moisture drops, and localized pest outbreaks in their specific plot. The government AI model successfully de-risks the bureaucracy. It reduces the cost of credit and tightens administrative efficiency, but it does not de-risk the crop or change the physical mechanics of how a farmer planting a seed. That physical execution gap is the target of the SMART FPO model. This phygital approach manages an entire village as a single coordinated industrial enterprise. In this model, the farmer-producer organization acts as the primary investor. It absorbs the massive upfront capital expenditures required for hardware like commercial drones and e-mobility fleets, offering the farmer a comprehensive natural farming subscription. By absorbing that capital risk, the FPO systematically removes technical and market risk from the farmer's shoulders. AI coordinates the exact application of a 36-stage biococktail spray protocol, ensuring crop quality through strict industrial precision. The ecosystem also engineers a circular bioeconomy pipeline. AI routing algorithms manage the micro-logistics of daily bovine waste collection directly from individual village sheds. Look at the scale of these facilities. That collected waste is fed into localized biohubs, where it is converted into shelf-stable industrial assets like biogas and biodap fertilizer. The profit from processing remains anchored inside the village. Retaining that wealth at the hyper-local level drives direct socioeconomic impact. It generates daily liquidity for households and builds a professional rural middle class, empowering thousands of financially independent women known as Lakhpati Bidis. But there is a ceiling to this approach. This model requires intense operational discipline on the ground, and recruiting certified, highly specialized tech talent, like drone pilots and refinery technicians, in deep rural areas is difficult and expensive. Plotting this on our framework, the SMART FPO engine lands strictly in the top left. It achieves maximum operational action, but its data and impact remain intensely local. The FPO model guarantees high-quality physical yields and immediate liquidity for the community. Yet, due to its heavy operational complexity, it cannot rapidly scale across the country without a frictionless, verified administrative baseline beneath it. The headline insight for the industry is this: digitizing Indian agriculture requires a mandatory stacking of both frameworks. To use an agricultural metaphor, the government AI model is the soil. It provides the necessary foundation of verified identities, standardized open APIs, and macro-level mapping. The SMART FPO model is the seeds and the harvest. It provides the actual physical execution, the market de-risking, and the industrial quality control required to generate cash flow. This vertical ecosystem map illustrates the synergy. Operational and yield data flows upward from the village to the state. This ensures the government maintains a macro view of national food security, while the individual farmer maintains micro-control over field profitability. Achieving a modern green revolution requires both layers. A national API cannot physically farm a field, and a local FPO cannot scale without standardized identity protocols. For builders, your investment strategy must adapt to this stacked reality. If you are a fintech innovator, rely on the government AI layer for baseline identity verification and risk assessment. Then, integrate directly with smart FPOs to design blockchain-backed liquidity instruments that finance their upfront capital expenditures. If you are an agritech builder, stop trying to rebuild macro weather maps. Focus your engineering talent on the smart FPO operational layer. Build localized computer vision tools for identifying crop stress, and develop routing algorithms for village-level logistics. If you are in public policy or edutech, shift your focus away from basic labor training. You need to start building certification frameworks for smart FPO professionals, the drone pilots, farm managers, and biorefinery technicians required to run these bottom-up hubs. The ultimate output is a zero-chemical, highly profitable agrarian economy. That outcome is only reached by building hyperlocal operational muscle directly on top of a national digital nervous system.